take a look at the domain and range of the toolkit functions. And the first function is the constant function, which is of the form f of x equals some constant c. In this case, f of x is equal to 2, which is just a horizontal line. We can see that any horizontal line would have a domain of all real numbers. So we'll write it in interval notation as negative infinity to infinity. And the range only consists of just one number, which is whatever the constant is in the given equation. So in this case, the range is just 2. Okay, but in general, you could write the range as c. The identity function is of the form f of x equals x, which is a linear function with a y-intercept of 0 and a slope of 1. And from the graph, we can see that the domain is also the set of all real numbers, and the range is the same. Okay, the next function is the absolute value function, or f of x equals the absolute value of x. It's a V-shaped graph, and some of the points on the graph are when x is negative 2, y is equal to the absolute value of negative 2, or just 2. When x is 0, y is equal to 0, and when x is 2, y is equal to 2. So I would encourage you to memorize these special points or memorize the pattern to create the graph of all of these toolkit functions. And the domain is all real numbers. And the range starts at 0 and then goes to infinity. So bracket 0, comma infinity. For the quadratic function, f of x is equal to x squared, we see that it consists of some points like negative 2, comma 4, 0, 0, and positive 2, comma 4, and is therefore a U-shaped graph. And the domain is all real numbers, but the range is just from 0 to infinity. Okay, the cubic function is next, which is of the form f of x equals x cubed. And you can see that the shape of the graph is still a curve, but it definitely looks different than the quadratic, in that here we have some points like 1, 1, and I don't have any points in quad 2 or quad 4, but I do have some points in quad 3, and so the opposite of each of those values, if we have a 0.11, then we have negative 1, negative 1. Okay, and we can see that the graph spreads to the right and to the left, and therefore the domain consists of all real numbers. And the range, because the graph spreads down and up, the range is the same. Okay, the reciprocal function is of the form f of x equals 1 over x. The domain is not all real numbers. Okay, f of 0, which is 1 over 0, but 1 over 0 is undefined mathematically, so there is not a point at x equals 0. And therefore, we're going to write this domain in words. It may be a little bit easier. We could just say it's all real numbers except x equals 0. In interval notation, we're going to write two regions. We're going to write an interval for this region on the left, and then we're going to write an interval for this region on the right. This would be from negative infinity to 0, put parentheses at 0, union in the middle, and then starting back at 0 again, so from 0 to infinity. And we would look at the y values to determine the range, and we see that this graph also has many y values except for y equals 0, and therefore the range is going to be written in a similar manner. Okay, from negative infinity to 0, union from 0 to infinity. And another toolkit function is the square root function, which is f of x equals the square root of x. And we can see that some x values do not exist on the graph, and that's because when x is a negative number, we end up with a non-real solution or a non-real output. Therefore, only values of x that create a real number output are going to be in the domain. And so if you look at the graph, we can look from left to right to say that the domain is from 0 to infinity. And then the range, look down to up, and the range is also from 0 to infinity.